Okay, so in this example, I'm going to show you how to work a two-sample t-test, for the difference of population means, with the assumption that the population variances are unequal, which allows us to use Welch's approximation. So I've got an example here with raw data, and we're going to do all this analysis in JUMP. What I've also done is I've pasted the template for the two-sample t-test using Welch's approximation in here, and we'll make use of that as well. It'll help us to organize our thoughts. So let's give a look at the question. It says a medical researcher wants to study whether a diet deficient in vitamin E affects the mean amount of vitamin A stored in mice. She selects two samples of 15 mice each. Group 1's called the control. They're fed a normal diet. Second group called the treatment. They're fed a diet deficient in vitamin E. She collects the following data, which, as you can see, lists the amounts for vitamin A for each of the two groups. It says, can the researcher conclude that the mean amount of vitamin A for mice on the deficient diet is less than the mean amount of vitamin A for mice on the normal diet? All right, so another way to say that is the control groups vitamin A greater than the treatment groups. And they're telling us to use a 1% level of significance. All right, so when I look at this, who we call population 1 and who we call population 2, that really doesn't matter for the template. But I know from experience when we use JUMP, JUMP, I believe, does the test in a certain direction. And I believe it always it looks at the populations and subtracts them in the opposite direction that we have them listed here. So I think it would be best for us to go to JUMP first and let JUMP do the difference for us. Let it go ahead and do the hypothesis test. It'll crunch all this data for us. So the only thing I know for sure right now is that the two groups have 15 each. I got that much. And I know the alpha level is 0.01. But all this other output, I believe, we're just going to be able to grab from JUMP. And I'm going to hold off identifying who's population 1 and population 2. And you'll see why when we import that data into JUMP. It'll make a lot of sense to you. So let's go ahead and go to JUMP. And now, actually, you know what I've done? This question is from the textbook. And it's in chapter 13. I believe it's question number 23. So in my math lab, when you are in my math lab and you click additional resources, there's this data sets link, which opens up a web page that has all the data sets from the textbook. This question's in chapter 13 and it's number 23. So when you click on that, it says 23.csv. CSV stands for comma separated values, which that's just a text file that has a data value, then a comma, then a data value, then a comma, and ... And then when you open it, it would open up in Excel. Now, I just clicked it, so it downloaded it to my downloads folder. So what I'm going to do is I'm just going to go to JUMP and let JUMP import the data for me. So I'm going to go to File, Open in JUMP. And I'm in my downloads folder on my PC. And I believe if you click that, it puts it in your downloads folder by default, unless you've changed it. But there it is, 23.csv. So I'll double click it. And here you have it. It imported the data for me into a JUMP table. And as you can see, it's just a descriptor, who it comes from, the control or the treatment group. Notice the control is listed first and the treatment's listed second. And if I look at all these control results, the majority of them are in the 3000s. So I would suspect the mean of that to be in the 3000s. And if you look at all the treatment groups, the majority, not all of them, but the majority of them are somewhere in the 2000s. So I would expect the mean for that to be, in the 2000s. So when I run this test in JUMP, I'll be able to tell who's who by looking at that. If it doesn't label it for me, I forget how it looks. All right, so let's go to AddIns, statistical calculators. Remember, we have calculators that do this for us. Hypothesis test for two means. So let's select that. All right, first thing it asks you, it's wondering, what are you giving me? Are you giving me raw data or are you giving me statistics? All right, well, we got the raw data. Pick a group containing the names. All right, so here we go. Group that has the names and tell me where the data is. Okay, so that's going to be the amount of vitamin A. Okay, so let's say okay. All right, so let's see what we got here. Choose the type of test, t-test, right? Choose the variance option. All right, we're using Welch's approximation because we're assuming unequal variances. All right, so now check it out right here. This is what I was talking about. Mean 2 minus mean 1. Now on my template, notice I have it as mean 1 minus mean 2. So, it matters who we call 1 and 2. We got to be careful there. So if I go back here, yeah, here we go. Look at the jump output. So again, the control group, as you can see, those values for the most part are in the 3000s. So sample 1 mean, notice jump is saying that the mean of sample 1 is 3433. It's calling the controlled group group 1. And group 2, it's calling the treatment group. And notice that means only 2540. And that makes sense too when you give a quick glance at this data here. All right, so let's go ahead and finish this off. So it looks to me like so in other words, think about it. It says when you take mean 2 and subtract off mean 1, what's going to happen? Well, when I take 2540 and subtract off 3433.33, clearly that's going to be a negative answer. It's going to be less than 0. So this is going to be when you take mean 2 and subtract off mean 1, you're going to get a less than scenario. All right, the significance level, we know that was 1%. So let's fix that, 0.01. And let's reveal the decision. All right, so I think we're all set up here. So let's go ahead to the template and grab all this information. We could fill it out. So if I go ahead to the template now and pull up, maybe I could shrink this a little bit so we can kind of see them both at the same time. I'll do my best here. All right, so population 1, I'm going to go ahead and call them the control. Population 2, that's the treatment. So the X bar one was 33.3 about. And the standard deviation of that sample, 355.4. All right, the X bar 2 is 2540. And the standard deviation of that second group, 407.6. As you can see, those standard deviations are pretty different. So that assumption of unequal population variances kind of does make sense. All right, the p-value for this test is essentially 0, as you can see, right? That's right over here, the p-value. And we know when the p-value is smaller than alpha, we reject the null hypothesis. Critical t-score, it gave it to me. Negative 2.4699. All right, let's round that to negative 2.47. I would imagine jump did not use this little calculation here. That little calculation right there, the degrees of freedom, the smaller of the degrees of freedom for the first sample and the second sample, which for both of them would be 14 regardless. But there's, Welch's t-test has its own formula for the degrees of freedom, and it's a mess. It's a real disaster to calculate, and it takes time. So in practice for, in education, for teaching purposes, most teachers usually play on the safe side and use the smaller of n1 minus 1 and n2 minus 1. So we don't need to worry about that because we don't have to look up that critical score because Jump gave it to us, which is kind of nice. All right, so let's go ahead and finish labeling our picture. So now remember, we're going to be doing a less than scenario. So let me blow this up. So remember, Jump is doing it in the opposite direction. Jump is taking 2 and 1, so I'm going to adjust that. And we are doing a less than test, a left-tailed test. So let me shade that region over here. And I don't have a way in Jump to do it in this direction, mu1 minus mu2. So that's why I changed the direction here. So this is my critical t-score. And that critical t-score is negative 2.47. And this is 0.99. This is alpha equals 0.01 for area. So here's my fail to reject region and reject region. All right, so we'll reject the null hypothesis, HO, if the testing statistic is less than negative 2.47. All right, so let's go ahead and grab the testing statistic. Now, we know the result of the test. Jump told us. And we also checked it out with the p-value method. We know it's a rejection scenario. We know the testing statistic is landing in the critical region. But we're just, kind of mapping out the whole test and making sure we understand all the details of the test. All right, so the T-score, which is the critical value. The testing statistic. Negative 6 point, let's call that 6.40. So this value here, negative 6.40. Now that is way the heck out here. Like it lands way into the critical region, right? It's really far out there. Clearly, when the testing statistic lands that far into the critical region, we're going to reject the null hypothesis. So reject H sub 0. Now, the standard error, Jump gave us that too. Right here, the standard error of the difference, 139.631. So this value here is 139.631. And this value right here is going to get substituted in there if you were to work that by hand. Now you might wonder, why do I even need to write that down if Jump is just, giving me my testing statistic? Well, if you want to work the confidence interval by hand, or if you just want to have a better understanding of what's going on in terms of calculating the testing statistic, it's nice to know that value. All right, so now what? Well, what I like to do is once I know what I'm doing to the null, I like to say what I'm doing. So I go right next to the null and I reject. All right, so that means what's going on here with the alternative. All right, well, obviously, I will accept that. All right, so what am I accepting? I am accepting that, in fact, the treatment group is significantly smaller than the control group. So based on the given information, the population mean amount of vitamin, and I believe that was vitamin A. Let me give a look there. I forgot already. Yep, of vitamin A is significantly less for the experimental group. All right, now, honestly, filling out this entire template when you're doing my math lab questions, that's really something that's on you, and you have to make a decision if you feel you really want to do that. I created these templates to help you with your overall understanding of the topic. So you make that decision. What this template does is I really think it nails down, it shows you, the traditional method of hypothesis testing, which involves, this whole idea in here with the testing statistic and critical values, but at the same time, it allows you to use a more modern method of a p-value approach. And again, as far as why did I leave the degrees of freedom calculation blank, in practice, we use n1 minus 1 and n2 minus 1. We take the smaller of that, to speed things up. And that's because the degree of freedom calculation is a little messy for Welch's t-test. It's not as simple as the pooled scenario. Some statistical programs actually give you the degrees of freedom calculation, and I don't see it in here. There may be other statistical calculators out there that I don't have. I had you add in a couple of statistical calculators, and I think they do a great job. This one has its issues. I would like to be able to reverse the order of these if I felt like it. They're forcing me to do mean 2 minus mean 1. And what if I feel like doing the other direction? The argument there naturally is that, you could just switch the groups around and play it that way. But I really think that it's a better idea if they just gave me the option. But, here it is, and I think it does a fine job. So if you have any questions on this, feel free to email me, and thanks for watching. I hope this helps you.